Hello, I'm Nadia. I'm part of the spacecraft team here at GLE, and today we're going to be going over Activity 2, the seismometer. So in this activity, you will be using the accelerometer like a seismometer. So we want to analyze how the Lunasat reacts to different items being dropped near it, so what sort of acceleration it will read from the impact. However, do be careful to not drop anything on the Lunasat itself. So to summarize, our goal today is for teams to be able to read data from nearby impacts of varying magnitude. So just some background info, the moon is seismically active and so it has moonquakes. These shallow moonquakes have been detected from several Apollo missions, and we expect the Lunasat to demonstrate its abilities to detect these moonquakes. So the materials you're going to need for the activity today include a Lunasat, a computer that has Arduino IDE installed, FTDI, and then associated cables, as well as a flat surface, a paperclip, a marble, and then the Activity 5.2 worksheet seismometer that you will follow along with. And then as for the code, you're going to need the accelerometer basic example sketch code, which you can find here if you go up to File and then Examples, and then down to GLE 2023 and Module Sketches. If you go to Module 5, you'll find the accelerometer basic example, and if we open that up, one second. It looks like this. So we'll start by, once your Lunasat is plugged into your computer, you can go ahead and verify it with this checkmark button. We'll give that a bit. Okay, and once it's verified, we can click the upload button next to it. And then you also have to wait a bit for that. Alright, so now that we've verified and uploaded, what we're going to do next is we're going to come up here to Tools and click on the serial plotter. So if we drag this up, this is what the serial plotter should look like when you put it into full screen. Alright, so the first thing we're going to do is we're going to gather our materials. So go ahead and grab your paper clip, the marble from the kit, and an object or a heavier object of your choice. This could be roughly the size of a golf ball. And then go ahead and place the Lunasat on the table. So the first thing we're going to do with the Lunasat on the table is drop the paper clip next to it. So we're going to record the maximum acceleration on any axis around the time the object is dropped. The next step we're going to do is drop the marble next to it at approximately the same height. Go ahead and also record the maximum acceleration on any axis around the time the object was dropped. And then finally, with the Lunasat on the table, drop your heaviest object next to it, again at the same height. You may also use your hand or make a fist and hit the table. Record the maximum acceleration on any axis around the time the object is dropped.